Hello and welcome to Amateur Radio Topics. My name's Kevin, VK6 Lima Whiskey, and this is episode number 5. And today we'll have a chat about quad antennas, quad loops. So we've discussed mainly dipole type antennas, single wire antennas in previous episodes, and we've had a look at also antenna analyzers and the software that can be used for modelling antennas. But have a look at some other antennas now, one of which is quite interesting is the quad antenna. So the quad antenna is a loop, and it's called a quad, I think, because primarily people tend to arrange these antennas in the form of a square. But it can be any shape. It can be a triangle, it could even be a circle, it can be an inverted triangle, it can be an oblong, rectangle, it doesn't have to be a square. And quad loops are quite forgiving in terms of the characteristics. So a quad loop essentially is normally one wavelength long for the band of choice. So it's a full wavelength. So it occupies, or it needs twice as much wire as a dipole, which is half a wavelength. The quad has some advantages over a dipole. There's a small amount of gain, maybe 1.5 dBs gain over a dipole, depending on how it's configured. It's certainly a quieter receive antenna than a dipole. Electrical noise doesn't seem to affect it quite as much. They can be erected close to the ground and you can still get fairly good results. It can be configured in such a way that the radiation is horizontally polarized, or you can feed the antenna in another position, maybe in a corner or towards a corner of a loop, and you will get vertical polarization. So that can be useful as well on the low frequency bands. One of the problems with the quad antenna is that they're a little bit more unwieldy than maybe a single wire antenna. It can be a little bit more difficult to get them up into the air and keep them up there at a decent height. And this becomes more of a problem if you're building a multi-element quad antenna. Then it's a three-dimensional type antenna that is not quite as stable as maybe a traditional beam antenna. But quad antennas work very well, and they have quite a nice feature which is not probably intended, but it always seems to be the case when I build a quad antenna, and that is if you build a quad antenna for say 40 meters, it will exhibit an acceptable SWR on the higher frequencies. So if you build it for 40, it'll work quite well on 30 meters, 20 meters, 15 meters, 10 meters, probably with an SWR of somewhere between 2 and 3 to 1, which is quite acceptable for general operating. And also with the quad antenna, you probably get a slightly lower angle of radiation broadside to the antenna. As I mentioned before, you can configure it for either horizontal polarization or vertical polarization. And the vertically polarized loop does actually work quite well. And if it's a triangle, you feed it close to one of the corners. And if it's a rectangle or a square, again, you feed it close to a corner. And this changes the characteristics of the antenna. You get a vertically polarized pattern, and this can be obviously quite useful for working DX. It doesn't need any ground plane or radial wires or anything like that. It's a vertically polarized antenna which is obviously suspended above the ground. So quad antenna is pretty versatile. It's essentially quite a low impedance antenna, so no matter where you feed the quad, the feed impedance is probably going to be somewhere around 120 or maybe 150 ohms at the feed point. So obviously if you feed it with 50 ohm coax, you will have a slight mismatch. You may have an SWR of 2 to 3 to 1 on the design frequency. This can be overcome obviously with a antenna matching unit in the shack, except a small amount of loss on the coax line to the shack, or you can construct a quarter wave matching transformer from a high impedance piece of coax. So if you have a 50 ohm coax running to the shack, and the antenna has a feed point impedance of around about 120 ohms, 150 ohms. It's going to be something around that figure, depending on how high it is above the ground. Then you can construct a quarter wave matching transformer out of 75 ohm coax that goes between the quad loop antenna and the existing coax you've got running to the shack, and that will transform the impedance down and give you a better match into your 50 ohms, and you'll probably end up with a match of somewhere around about 1.5, maybe 2 to 1, but it would be a better match than if you just go straight in with the coax. As I mentioned before, the additional loss for these types of SWR figures on the HF bands essentially is quite small, particularly on 40 meters. It's not going to be something that you would even notice, but it is nice to keep everything happy in the shack, and your transmitter may not entirely like it if you've got a high SWR. If you've got a matching unit, that's where that comes in. A lot of transceivers these days have those matching units built in, and they'll happily handle an SWR around about 3 to 1 anyway. So that keeps everything working nicely. Now, if you can get this antenna up into the air at a decent height, it will work extremely well. They also seem to work quite well low to the ground. This is a matter of conjecture a little bit, because obviously it depends on your location, depends on the ground conductivity, depends on other obstructions you may have around. So this is where things get a little bit subjective in terms of the results people have had with quad antennas low to the ground. It doesn't always mean that it will always work well low to the ground, but certainly people have had good results. I've had good results with quad antennas fairly close to the ground, and I've also had pretty good results feeding them either on a horizontally polarized basis or vertically polarized basis. And there's a really neat way you can switch between the two, and it's probably something that I might leave to a later episode, but you can have a quad antenna for a given frequency, have a couple of matching transformers at each feed point, and switch between the two. So you can switch between horizontally polarized transmission and reception and vertically polarized, and that's quite useful under certain band conditions, because it's not always the case that one type of polarization is always the best polarization. Quite often the signals that come in, particularly DX signals, can be scrambled a bit, they can be cross-polarized. The ionosphere has all sorts of effects on the signal when it arrives at your station. So it's really useful to be able to put this into place and have a simple switching unit with a relay and a couple of transformer type coax lines that run between each feed point on the loop, and works quite well with a triangular type loop setup. So we can explore that a little bit later on, and I'll probably put something onto our website about the configuration, a bit of a diagram showing you how to put this together. And again, that same antenna will still work well no matter which polarization you choose to use. It will still work quite well on the higher bands as well. It won't always guarantee you to have a low angle of radiation, but it would be quite an adequate antenna. If you've only got space for a single antenna, a quad loop is a really good design. The other way it can be configured is to mount it horizontally to the ground. So quite often with this you need 3 or 4 supports, and you mount the plane of the antenna parallel to the ground at maybe 30 to 40 foot high. It exhibits the same sort of feed point impedance. You've got the same sort of matching issues. It's on the band of choice. It works very well. It also works very well on the higher bands, higher frequencies than the band of choice. And it gives a slightly different radiation pattern if you mount it parallel to the ground. It's probably a little bit more of a high angle radiator in some respects on the band of choice, unless you can get it up very high. But a lot of people like this. Some people just are happy to have an antenna that will work for DX, work for local contacts, put out a good signal. It's got a low visual impact, which is something that they may want. And if you've got trees arranged around your property, or you can use the house, or maybe trees and a mast, you can normally manage to find 3 or 4 supports. If you can only find 3, well, obviously it becomes a triangular shape. If you can find 4, all the better. If you can only put the loop up as a rectangle, then that's fine. It doesn't have to be 4 equilateral sides. It makes no difference really in the overall scheme of things whether it's a rectangle or a triangle or a square. It's really very forgiving antenna indeed. So it's a good antenna to experiment with. You can model it using Easy NEC, and of course you can add elements to the quad antenna. You can add a director or a reflector to create a beam antenna, but we'll come to that in a later episode when we discuss multi-element antennas, beam antennas, antennas that have some gain. So I'd encourage you to take a look at the quad. Really nice antenna to work with, and very easy to configure. Not difficult to get working at all, and gives you some advantages on receive, which is always welcome. Of course, you can also have several quad antennas, one mounted inside another. So if you have a quad for say 20 meters, and you then build another quad for 15 meters, put another quad inside that for 10 meters, they will all sit concentrically on the same support, which can be a mast, a tree, part of the house, a tower, or on a spreader arrangement if you wish to rotate the quad. And you can feed these three loops with the same feed line if you wish, or you can have separate feed lines, which probably is advisable. You can use the quarter wave matching transformer method we discussed earlier. You can even use open wire line with the quad. That works quite well, but obviously you do need a tuner either at the base of the mast or in the shack. So there's a number of ways you can configure the quad, and certainly it's a great antenna to experiment with. It's a good DX antenna, it's quiet on receive, and essentially even a single wire quad will give you some multi-band capabilities. Now, the wire that is used is not critical. It's the same type of wire we've been discussing for other wire type antennas. I quite like using something like 2mm or 2.5mm enamel copper wire. I never really put my antennas under that much strain that the stretch factor is going to be an issue, and it's fairly easy to model the antenna with that type of wire. Generally speaking, if I model something using modeling software, the end result is pretty well what I've modeled, and I can confirm that with the antenna analyzer. Of course, that's another really useful tool, as we discussed before. But the modeling software works very well. If you are using plastic or PVC type covered wire, you've got to make some assumptions as to the velocity factor. So generally speaking, if you've got that type of wire, the velocity factor might end up being around about 0.95, or you end up with a length that's 95% of what the full length would be if you were using bare enamelled copper wire. And that's the effect of the PVC or the plastic has on the electrical length of the wire you're using. So from a modelling point of view, it's easier to use bare wire or enamel copper wire, and practically it's okay. In the past I have used hard drawn copper wire for various antennas, hard drawn stranded copper wire, all sorts of things, and eventually I've just come back to using the enamel copper wire. It's easy to work with, it doesn't really kink. If you do get a kink in it, you can straighten it up because it's essentially soft enamelled. Some people do report that the wire does stretch if you put it under tension, and that's true, it will do. But generally speaking, I've not found that to be too much of a problem, mainly because I don't tend to build my antennas with lots of tension on the wire. Maybe this becomes more of an issue if you've say got two masts or two trees and you want to string a wire between them and you want to get a degree of tension on it. Then that becomes more of a problem. I tend not to use the plastic coated wire for the reasons I mentioned about the velocity factor, but there's plenty of wire on the market that is sold for antennas with a coating, but it will always have a velocity factor. So anywhere between maybe 1 and 10% reduction in the length of the antenna that you need to calculate. But you can do that. You can do it quite easily by comparing that antenna with the PVC coated wire with another antenna made up for the same frequency with just enamel copper wire, and a fairly easy quick calculation will give you the difference in terms of the velocity factor between the two antennas. To do that, ideally you do need an antenna analyzer. It's pretty hard to do it without one. So yes, so the quad can be put up with virtually any sort of wire. If you're prepared to do the cut and try method, then you can use anything. If you're not going to model the antenna, it doesn't really matter. And we can certainly put some useful formula on the website to help you with setting up an antenna just using formula and cut and try. It takes a little bit longer to do, but it's the way that we always used to do it before we had modelling software. And there's nothing really wrong with putting an antenna up to a formula, seeing what frequency it resonates on, and then adjusting to suit. It's pretty simple, really. The other useful feature of a quad antenna is on receive, and you can in fact use a smaller version, a cut down version of a quad antenna, small quad, small loops, close to the ground, maybe arranged with a central feed point, and relays to switch different directions. And this can give you significant signal to noise benefit, particularly on the low bands. It may not be such an advantage on the high bands, but maybe 40, 80 and 160. Small quad loops are very good for receive. You may need a preamp under certain circumstances, but personally I've found with all my receive antennas, whether they be beverages, small dipoles or quad loops, or even beverages on the ground, with the preamp that's already in the radio, I find that more than adequate in terms of boosting the signal, the receive signal. The whole idea on the low bands with receive antennas is to try and get a better signal to noise ratio. It's not necessarily trying to get a stronger signal, you're just trying to cut the noise down. A small quad loop's got the advantage of being able to be rotated as well, so you can arrange a small loop to be rotated to null out the noise in the offending direction. And these days on the HF bands and the low bands, there's plenty of noise that you'd rather not have, whether that's man-made noise or atmospheric noise. So the quad loop as a receive antenna is very useful on a small scale. It can be easily fitted into the available space, and it can really help you work DX on the low bands. Receive antennas will be part of another podcast. That's really quite a large subject to cover, and I think we need to look at that in its own dedicated podcast, or maybe 2 or 3 different podcasts covering receive antennas. I'm fortunate here, I've got quite a bit of space, so I've got beverage antennas, I've got small dipoles, I've got a beverage on the ground, and I've used small loops as well in the past to good effect. There's no one receive antenna that's perhaps going to be the best, and it's quite interesting if you've got receive antennas that you can switch. It's quite interesting to see sometimes the direction the signal's coming in from. It's not really always where you expect it to be, particularly under low sunspot conditions on the LF bands. So that pretty well concludes this episode covering the basics on quad loop antennas. There will be more information that I will place on our website, zigzagwest.com. If you've got any questions, you can email me on hamradiotopics@gmail.com. So thanks for listening, and 73s for now from Kevin, VK6 Lima Whiskey.